All right, we are going to look at now combining like terms and using the distributive property as well, but really focusing on combining like terms here. So first of all, a term is what's between the signs. So terms are separated by addition signs, subtraction signs, whatever. So this particular expression up here has 1, 2, 3 terms to it. Okay, it would be called a trinomial, which you'll learn about in future chapters, but because it has 3 terms, it's called a trinomial. Then we want to look at combining like terms, and in order for something to be a like term, it has to use the same variable and have the same exponent. So if I look down here and I compare 2x and 3x squared, they both have the same variable in them, they both have x's in them, but this is an x to the 1 and this is an x to the 2, and that does not make them like terms. They are not like terms. Where if I look at the 6y and the 4y, they each have a y in them, and they're both to the first power. So those would be like terms. When you add and subtract like terms, the only thing you add and subtract are what are called the coefficients, or the numbers that are out in front. So I would add 6y and 4y to make 10y, not 10y squared, but 4y plus 6y makes 10y. The only numbers I'm adding are this and this. Okay? All right, then we want to look at equivalent expressions. Equivalent expressions are things that have the same value. Okay? So for instance, the expression 2 plus 3 is an expression, and 5 is an expression. So they are equivalent since they have the same value. Okay? Over here, 2x plus 3x makes 5x, and 1x plus 4x also makes 5x. So 2x plus 3x and 1x plus 4x are equivalent expressions. Okay? Then, if they are in simplest form, it means that everything has been combined that could be combined. So I want to look at like terms and put them together where I can. So right here, I have a 2x and a 3x. Same variables, same exponents. So I would add the numbers that are out in front, or the coefficients, and 2x and 3x would make 5x. Same thing here. I could add a 5 with a negative 2, and 5 plus negative 2, or 5 minus 2, of course, would be 3. Okay? Like we've already referred to, the coefficient is the number that's in front. So in this expression right here, the number that's in front of the variable is the 3. So 3 is the coefficient. All right, here we go. I want you now to simplify each expression. If it's not possible, then just simply tell me that. So basically, I want you to look for like terms, terms that have the same variables with the same exponents. Typically, when you do this, you want to list your answers from the biggest exponent to the smallest exponent. So in this problem, I have a whole bunch of x's in here. I want to list my answers so that I use the highest exponent of my x first. So in this case, I have x's to the 2 second power, and I have x's to the first power. So I want to do the x's to the second power first, since that's a higher exponent. Okay, so these are like terms, a 5x squared and a 2x squared, since they have the same variable, x, with the same exponent squared. Okay. Again, all you're going to do when you combine like terms is add your coefficients, or your numbers out in front. So 5x squared plus 2x squared would make 7x squared. 5 plus 2 makes 7, x squared. And then, of course, I have this 3x right here that I can't combine with anything. I cannot make this be 10x to the third power, because I can't combine expressions that don't have the same letter with the same exponent. Okay? So that's all I could do there. All right, here, now again, you want to start with the highest exponent. And so I have x squared here and I have x squared here. And I cannot tell you how many people will tell me the answer to x squared plus x squared is x to the fourth. It is not. Again, when you add these, you only want to add the coefficients, or the numbers out in front. And in this case, it might appear that there are no numbers out in front. But I need you to remember that there are these imaginary ones right here and here. If there's not a number written out in front, assume it's you can assume it's a 1. So if I have 1x squared plus 1x squared, I have 2x squared. Right here, I have, again, imaginary 1x and an imaginary 1x. So 1x plus 1x makes 2x. Not 2x squared, not 1x squared, because you're not adding the exponents. You're only adding the coefficients or the numbers out in front. So that would be 2x. And then I've got this 4 over here that I can't combine with anything. And this would be my answer here. All right. On this particular one, now we have an x squared and we have a negative x squared. So there's a 1 right here and there's a 1 right here. So if I have 1x squared and then I subtract 1x squared, I don't have any x squareds left. I have 0 x squareds, and you don't need to write that. And we already know that 1x from the previous problem plus 1x. Again, add the numbers out in front. 1 plus 1 is 2 of those x's, not 2x squared. And then, of course, I have this minus 2 over here. All right, now we're going to kind of combine a little bit of the distributive property and combining like terms. So when I get to this problem here, obviously you have this 2x that I'm not going to touch right now. But I have this thing in parentheses, this quantity in parentheses that I need to distribute. So I have a positive 7 right here that I will distribute through. So positive 7 times x is 7x. Positive 7 times positive 4 is 28. And then minus 6. And now you want to combine your like terms, okay? So I have 2x plus 7x with the same variable, same exponent, which gives me 9x, not 9x squared. And then 28 minus 6, of course, gives me 22. All right, this time we've got 2 things we need to distribute, so I think we can handle this. 3 times x is 3x. 3 times 2, positive 2 is 6. And then I have positive 2 times x is 2x. Positive 2 times 5 is 10. Okay, combine your like terms. 3x plus 2x makes 5x. 6 plus 10 makes 16. Okay, I want you to try the next one on your own and see if you can handle that. Okay, I want you to hit pause on the video and see if you can come up with the answer and then replay it. All right, and the answer is 5x plus 7. So hopefully you got that. All right, on the next one, I know they have fractions, so don't freak out. Okay, here we go. 5 times x, we know is 5x. 5 times 1/5. Now remember, multiplying by 1/5 is really the same as dividing by 5. So 5 divided by 5 is just 1. Okay, or if you want to multiply it out up here, remember those 5 cancel and you just get 1. Okay, so I have 5x plus 1 plus I have 8 times x is 8x, and 8 times 1/4. I'll do this up here so you can see it. 8 times 1/4, 1, 2. Okay, 2 times 1, of course, we know is 2. You can also, when you're multiplying by 1/4, is the same as dividing by 4, and 8 divided by 4 is 2. Okay, combine your like terms. 5x plus 8x we know is 13x, and 1 plus 2 we know is 3. Okay, and our very last one, here we go. X times x. People tell me all the time that that's 2x. X times x is x squared. X plus x is 2x. Okay, so I have x squared plus x times 2, which is 2x. Positive 3 times x is 3x. Positive 3 times 4 is 12. Okay, combine your like terms. You can't combine your x squared with anything. That has to stay by itself. But I can combine the 2x and the 3x since they have the same letter with the same exponent and make that be 5x. And then I have this 12 at the end that I have not touched. So here we go.